Hello, everyone. So today we're going to start a new page in your notebooks called Fronts. We talked yesterday about how air masses are formed over different parts of the world, whether it's over oceans or land and cold or warm. And those air masses have different properties because of that, different densities, different temperatures. So when you have two of those air masses that meet, a front is created. So that's what we're going to talk about today. I did make a sheet of my own so we can kind of follow along. It's going to be a little bit different looking for you. I put, kind of forgot about my definition of fronts, so I put it underneath. This is going to go on top. So if you wanted to start just kind of laying out your sheet, you're just going to have one definition on the top, which is on the next slide, and then the whole rest of the sheet will be taken up by this chart. Mine is kind of crammed in here, so you can kind of fill up the whole rest of your sheet with this chart after you just write down this definition of fronts. So fronts, oops, let me get myself out of the way here. Fronts are where air masses meet but do not mix due to different temperatures. So fronts, as I was saying, are where two air masses meet but don't mix because they have those different temperatures, they have different densities, and when that happens, they become a front. And so you have, either warm air pushing against cold air or vice versa, and because they have different densities, it causes one of the masses to rise. That's where we get that accumulation and precipitation, you can see on this, and you guys don't have to know the names of the clouds this year. I'm sure you remember them from previous years, but this is how different clouds are formed from when these air masses meet. So let's move on. You should have this down as your definition of fronts. The first thing I just want to show you is the four different types of fronts. You are going to have this on each slide. You're going to be able to see these symbols again. But if you wanted to start your chart, on the left-hand side, you're going to write down the names of the fronts, and then in the middle, you are going to draw the symbols, okay? The only other thing that I want to show you on this is that the direction of the movement of the fronts are indicated by where the shape is pointing. So you can see the triangle is really obvious. The triangle is pointing towards the way that the front is moving across the country or, across the world. And then there is this front here, the stationary front. It's going in both directions, but again, the arrows are indicating the direction of movement. The stationary front actually doesn't move for a while, so that's why it's kind of going in both directions, but we'll talk about that in a second. Okay, so a warm front, you don't have to write anything down on the slide, I just kind of wanted to show you the direction of the movement. Again, here's our front, but it's because you've got this cold air mass, right, and this warm air mass, and the warm air is pushing the cold air. It's got more strength, so it's pushing that cold air, but the warm air is rising above the cold air because of the density of the warm air. So cloud development is forming. The cold air is being pushed away, but clouds are forming because that warm air is going above the cold air that used to be there. So a warm front is moving faster than that cold air. It's moving faster, so it kind of takes it over. Excuse me. If the warm air is humid, then you have scattered showers, and if it's warm, then it's just clouds. So again, it all has to do with where those air masses are forming. If you've got a continental air mass, it's going to be dry and cloudy because of that warm front. And if you've got a maritime air mass, then it's going to be humid and you're going to have showers. So I want you to write down that warm air moves in, right? And that if it's humid, these are the types of weathers that you have to know are coming. So it's either showers or you've got clouds at the very least. Okay, and then a cold front, you've got this advancing cold air, and again, that warm air is pushed above it, but it's happening at a much faster rate because the cold air is overtaking the warm air. Again, you've got that cloud development at a front. In any front, if you just picture in any front, excuse me, there is always going to be cloud formation because one of the air masses is lifting above the other. So, excuse me. So you've got the receding warm air. It's actually being pushed out, and above the cold air, and this is moving at a much faster rate. So the faster moving cold air comes in, pushes the warm air up because it's more dense. The rising air cools and condenses and then forms more clouds. And then you could have a lot of precipitation in this case, heavy rain. Okay, moving on. So now we have, you don't have to write anything down here, but I just wanted to show you the difference between an occluded front and a stationary front, which we'll talk about more in just a second. The occluded front, you've got light rain and precipitation, and then the stationary front, this is the one where it showed that the two symbols were kind of competing with each other. It's actually just like it's stationary. It doesn't move, so it brings like continuous precipitation. Again, what we're seeing in all these fronts is that it does bring clouds and precipitation because those air masses are pushing air up, and it causes condensation, and which causes clouds or precipitation. So the occluded front, you've got cold air and warm air that are moving at the same time. Okay. Cold air, advancing very cold air, and then you've got receding cold air. Usually you're talking about similar temperatures in this case, but there is that warm air that's still lifted and causes the cloud formation and precipitation. So occluded fronts, they usually result in storms because the warm air is kind of caught between those two masses of cold air. So although one mass is usually colder than the other, it's still kind of trapping that warm air in between, above, but in between. And then you've got storms. And I wrote this really big for some reason, but it does usually result in storms. Then you have the stationary front, which is two masses that just collide and then they don't go anywhere. So when stationary fronts, it's when they stop moving. It's when warm and cool air meet, and then water vapor. It's just like the same stuff. You know, when you get those rainy periods for like days on end, it's because usually there's a stationary front. Do I have the picture in here? Yeah, there's your stationary front picture or symbol. So on our maps, you can see, if you see weather maps, you see all different types of fronts moving across the country at all times. So you've got a cold front here, low pressure system, high pressure systems, which means like sunny and not cloudy, but you've got this low pressure system moving and this cold front moving with it, which happens quite a bit. And then you've got a warm front up here, and you can see that there's snow, but this warm front's coming in, so it's probably going to get warmer in this area. You are actually going to work through some worksheets and determine the weather that's coming into different areas on those worksheets. I am going to save the rest of these slides for when we're together, because it's going to be kind of difficult for you to indicate where the fronts are on a PlayPosit video. But again, those worksheets will give you enough of a review, I believe. If you have any questions, let me know.